Hi, this is Somaiah, working as Assistant Professor in the Department of Mechanical Engineering at the Institute of Aeronautical Engineering. So today I am going to discuss about the derivation of Euler's equation of motion and the various forces involved in the Euler's equation and how to derive Euler's derivation as part of fluid dynamics. So in the previous classes we have gone through fluid kinematics and velocity, acceleration of a fluid particle, etc. So in the fluid dynamics, the difference between fluid kinematics and fluid dynamics is the fluid dynamics it considers the various forces which causes the motion of a fluid. So, but whereas in fluid kinematics, it doesn't regard the various forces which are causing its motion. So that is the main difference between fluid kinematics and fluid dynamics. If the forces are considered, what are those various forces which are to be taken into the account in order to solve the various energy equations? These energy equations are useful for solving various fluid flow problems in case of viscous flows and different types of flows, and in turbulent flows. In the various flows, we will solve the problems. So, in order to solve various problems, we have to see various forces which are causing the motion of a fluid, due to which, due to those forces, the fluid flow occurs. So, if you consider such forces, then this particular field is known as fluid dynamics. So, a fluid in motion is subjected to several forces, so which results in the variation of acceleration and the energies involved in the flow phenomenon of the fluid. As such, in the study of the fluid motion, the forces and the energies that are involved in the flow are required to be considered. This aspect of fluid motion is known as fluid dynamics or dynamics of fluid flow. So these forces can be divided into three groups. So various forces which are going to cause the motion of a fluid flow can be divided into three categories. One is body or volume forces, and another one is surface forces, or also you can call these forces are area forces, surface forces or area forces, and another one is line forces. So these forces can be categorized into three groups. So whereas the volume, surface area forces, also line forces. The body or volume forces which are proportional to the volume of the body. The examples includes weight, centrifugal force, magnetic force, electromagnetic force, etc. So these are similar to the volume of your body. So while considering the various forces, if the weight is considered, that comes under a body force which is acting on a fluid mass. Similarly, the surface forces are nothing but area forces which are proportional to the surface area. So which includes the pressure force. The pressure is its unit is Pascal, Newton for meter square. That means it indicates the area that the pressure force originated, otherwise which will be developed due to the pressure gradient. Where there is a pressure difference, there will be a pressure force is existing. So based on its unit also, you can understand that force is due to pressure. So pressure force is one of the example of surface force. Similarly, the tangential force or shear forces will also occur due to the, while the fluid is flowing, so there will be attraction between the fluid particles. That means the cohesive forces will be there. When there are cohesive forces over a period of time, so these will be emanating as a shear forces. So the shear forces are also tangential forces due to cohesiveness property of a fluid particle. There will be the shear stresses or tangential stresses, also due to viscosity. So the viscosity also occurs on the account of the cohesiveness property of a fluid. Similarly, another force is force of compressibility. Also force due to turbulence. These also comes under surface forces or area forces. Then line forces. The line forces are proportional to the length only. So by the name we can understand the linear forces or line forces are proportional to length. For example, the force due to surface tension. So the surface tension unit is force upon unit length. So therefore, so the force due to surface tension will be known as surface tension force, or is equals to linear force or line force. You can call it as line force. If there is a surface tension for fluid, there are different properties that we have discussed. So due to surface tension, there will be a force. That force is known as surface tension. Similarly, due to pressure gradient or pressure difference, there will be pressure force. So, like this, due to gravitation, gravitational force will be existing in a fluid. So, such type of forces due to various properties, the forces will also included into the fluid flow analysis. So, if you include these forces into a fluid flow for solving fluid flow problems, and if you consider all these forces and if you analyze the fluid flow, then you can call it as fluid dynamics. Like mechanics of solids, the dynamics of fluid flow is also governed by Newton's second law. So in the solid mechanics also, that is also governed by the Newton's second law. Similarly, the Newton's second law can be applied in the fluid mechanics also. So here, by applying the Newton's second law, as it states, the resultant force is equals to the product of mass and acceleration. So these resultant force and the acceleration will be acting in the same direction. So based on this law, we will consider the Newton's second law as a governing law, a governing equation. So by considering the Newton's second law, we will derive various equations which are useful for solving the fluid flow. So both acceleration and resultant external force must along the same line of action. Therefore, force and acceleration vectors can be resolved along the three directions x, y, and z. Corresponding equations can be expressed as sigma fx is equals to m into ax. So, acceleration along x direction and the resultant force is also about x direction. Similarly, along y direction and about z direction also. The forces can be resolved about three mutual perpendicularly. These three mutual directions will consider, and if based on the number of axes, coordinate axes taken into the account, about that the resultant forces can be derived. So now we will discuss the forces. Various forces will be considered in a fluid dynamics. So basically the first beginning in the beginning we'll consider the gravitational force is the primary force as a pressure force, and remaining forces also, but will also come into the picture. But the gravitational force is the primary force which will be acting on a fluid flow due to the gravitational gravity force will be acting, and this will be equals to mg. So fg is equals to force due to gravity is equals to mg. So here acceleration due to gravity is, and the F equals to, generally we will write resultant force is as per Newton's second law, F equals to ma. So but here due to gravity, so we can write F equals to mg. But so this fg for for unit volume, then you can write it as a rho g. So the gravity force for unit volume you can call it as a rho g. So this force we have to consider while discussing about fluid dynamics. So another force is a pressure force. This pressure force will be existing due to the pressure difference or pressure gradient. When a fluid is flowing through a pipe, on account of internal friction, internal surface roughness, so there will be pressure difference will be occurring over here. a period of time or a length of a pipe, you can tell the P1 and P2 they will not be equal because of there will be a pressure gradient. Due to the frictional losses, the pressure difference will be taking place between any 2 points. So due to this pressure gradient, there will be a pressure difference, and due to that, there will be a pressure force will be occurring. So the viscous force, F is due to the viscosity. On account of viscosity, there will be viscous force. So viscous force is basically that is due to the cosinus property, the attraction between the fluid particles, attraction between the fluid layers will take place, and these viscous forces will be called as shear forces or tangential forces. This will be generated on account of viscosity. So that is also one of the force which is to be included while analyzing the fluid dynamics. And the turbulence force, the force due to turbulence when the fluid particles will move in a randomized direction. In that cases, there will be forces will be generating, that is nothing but turbulence. Due to turbulence, there will be a force. Fluid particles move from one layer to another layer in a zigzag manner. While they are moving, they will be resulting the force due to the turbulence. So they in developing additional stresses, so which are also called as Reynolds stresses. Another force is force due to surface tension. So the surface tension is due to a cohesive property. So there will be attraction between the fluid particles. So when there is a surface tension is acting, and there will be a force due to which will be taking place. And the another force is the compressibility force. Force due to compressibility is denoted by Fe, is due to elastic property of fluid, and it is important only either for compressible fluids or in the cases of flowing fluids in which the elastic properties of fluids are significant. So now these are the 6 different forces which are going to be considered for solving the or for deriving the equations, then by solving various fluid flow problems. So the various forces are force due to gravity Fg, and due to pressure gradient, there will be Fe, and viscous force Fv. Then therefore turbulence force Ft will occur. Then force due to surface tension, compressibility force. These 6 forces will come into the will be considered for deriving the various energy equations or fluid flow equations. If a certain fluid in the motion is influenced by all the above mentioned forces, then according to Newton's second law of motion, the following equation can be written. As per Newton's second law, the resultant force is equals to product of mass and acceleration. So product of mass and acceleration equals to resultant forces. So the sum of the resultant forces, the force due to above, considered the 6 forces due to 6 different properties, will be considered. The sum of all those 6 forces is equals to product of mass and acceleration. And if you can resolve all these forces about 3 directions, so the fluid flow will occur about 3 different directions. If you resolve all these forces about 3 different directions, you can form the set of equations. So the equation 2 will be denoting about resolving of forces about 3 mutually perpendicular directions, about Fgx, Fgy, and similarly Fgz. So about z direction, x direction, y direction. Similarly, all the forces about all 3 directions. So summation of all the forces, all the 6 forces about all 3 directions, and the forces will be resolved along the direction of a acceleration component. So this set of equations in the beginning, we can resolve the forces, all 6 forces, and later what will be happening based on the application, based on the requirement, we can be eliminating some of the forces from the equation 2. Okay, suppose in some fluid flow problems, the force due to compressibility and force due to surface tension, these 2 forces are insignificant. If these 2 forces are eliminated from the equation 2, then you can write the remaining equation will be a summation of gravity force, summation of pressure force, and viscous force, then turbulence force. So this if you resolve these four forces about the three different directions, then you can call the particular set of equations is known as Reynolds equation. The equation 4 is known as Reynolds equation, where a force due to surface tension Fs is eliminated and force due to compressibility is eliminated, because in some of the fluid flow problems these are insignificant. The resulting fluid expressions, these expressions about the three directions, is known as a Reynolds equation of motion. Now, in case of viscous forces, viscous fluid flow, what happens? This turbulence force also insignificant. So, if you eliminate this force due to turbulence, then only the three forces will be reminded. One is force due to gravity, force due to pressure, and force due to viscosity, or shear forces or tangential forces. There will be Fv. So if you resolve these three forces, resultant forces about three mutually perpendicular directions, x, y, and z, and also the acceleration about x, y, z directions, and you can write this set of equations. So ma, as per according to the Newton's second law, you can express and you can derive the equation 6. So fgx plus fex plus fex, similarly about y direction and about z direction also. So this particular equation is known as Navier-Stokes equation. So these are known as Navier-Stokes equation. The viscous forces will become insignificant if the flowing fluid is ideal. So, but the majority of cases, if you assume is a for assumption only ideal fluid will be there, but in ideal fluid as it is not existing, you have to consider only real fluid. For real fluid, always there will be viscosity. If there is a viscosity, means that is a real fluid. But if you assume that if particular fluid is ideal fluid, then the viscosity becomes zero, negligible. So from the previous case, so if you are eliminating the force due to viscosity, this viscosity also you can eliminate. Force due to viscosity is eliminated. Then only the two forces will be remained. One is gravitational force, force due to gravity, and another one is force due to pressure. So this can be resolved again about three mutually perpendicular directions. Then that as per Newton's second law of motion, we can be deriving this equation 8. This equation 8 is known as Euler's equation of motion, or Euler's equations of motion. In Euler's equation of motion, only the two forces are considered. One is force due to gravity, gravitational force is considered. Another one is force due to pressure. So always there is a friction while the fluid is flowing between 2 points. So therefore, we can't avoid the gravitational force, also pressure force. So the Euler's equation will consider only these two forces, gravitational force and pressure force. So by considering these two forces and by including these two forces, we will derive an expression for a Euler's equation of motion. By considering a fluid particle along a streamline, we will derive Euler's equation. So for deriving Euler's equation, you have to consider a fluid particle. As shown in figure, a cylindrical fluid particle, you have to consider as it is moving over a streamline, along a streamline. So there are the different forces which are acting on a fluid particle is pressure force at inlet, that is pressure into area PdA, and another one is at the exit pressure force is acting, it will act in reverse direction, that is equals to P plus dou P by dou S into ds into dA. So this equation is achieved, otherwise you can derive based on the Taylor's series. By using Taylor series, we can derive this expression. At the inlet, if it is PDA, at outlet, what will be the pressure? P plus dou P by dou S into ds into dA. This can be derived as per the Taylor's equation. So the ds indicates the length of the fluid particle, and the weight of the fluid particle acts downwards, so that is equals to rho g into dA ds at an angle of theta. So the angle of theta indicates the angle between the weight of the fluid element and the fluid particle direction. So in this case, various forces considered for solving the Euler's equation are: the one is pressure force at inlet. Again, they are written. The pressure force is at the outlet in opposite direction is P plus dou P by dou S into ds into dA. And another one is weight of the element, so acting downward. The weight of the element acting downward, rho g dA into ds. So we know the theta. The theta is the angle between direction of flow and the line of action of the weight of the element. The resultant force on the fluid element in the direction of S must be equal to the mass of the fluid element, and acceleration in the direction AS. So F is equals to m into AS. F equals to m. As for Newton's second law, we will apply all these forces and we will derive an expression for Euler's. So the resultant force can be written like this. So by adding, these are the various forces which are acting on a fluid particle, and this is equals to mass times acceleration about direction s. If you apply in a Newton's second law, so we can be writing like this, because PDA will act in upward direction, therefore is positive, and the pressure force which is acting in opposite direction, therefore negative, minus P plus dou P by dou S into ds into dA, and this is due to the weight of the fluid particle, so which is acting downward. So rho g dA ds cos theta is equals to mass into acceleration. So about direction S is AS, mass of the fluid particle is rho dA ds. Weight of the particle is rho g dA ds. Weight of the particle is rho g dA ds, and mass becomes rho g. So its force becomes weight is nothing but rho g dA ds, and where if you consider only the force, then it will be becomes rho g dA ds cos theta equals to rho dA ds into AS. So one is pressure force at inlet and one is the pressure force from outlet, and this is the weight of the element acting downwards, and this is a mass. So weight is nothing but rho g dA ds, whereas rho dA ds is mass. Mass becomes rho into dA ds. So from this we have to derive about AS, as where acceleration is a function of v and t, as because the acceleration is nothing but rate of change of velocity, we can write as dv by dt, where v is a function of s and t again. So therefore, from the chain rule of differentiation, you can expand as is equals to dou v by dou s into ds by dt plus dou v by dou t into dt by dt. So therefore, we can write ds by dt is nothing but velocity v into dou v by dou s plus dou v by dou t. So this dou v by dou t is also become zero, as if it is steady flow, it becomes zero. So v into dou v by dou s is the expression for acceleration of a fluid particle along s. Now, if you substitute as in the previous equation, then the resultant force remains same, and as can be substituted like this. The as is nothing but v into dou v by dou s. Remaining expression becomes same. Then so if you simplify, this pda gets cancelled, then it becomes minus dou p by dou s into ds into dA. then minus rho g dA ds cos theta. So the vertical component of a fluid particle due to its weight, and this is a mass of the fluid particle rho into dA ds into v dou v by dou s. So this indicates acceleration. So now I am going to divide the entire equation with rho into dA ds. So that means it's a mass of the fluid particle. If you divide entire equation on either side with the mass of the fluid particle, then it becomes minus dou p by rho into ds, rho into dou s minus rho dA ds gets cancelled, minus g cos theta. Similarly, here only v dou v by dou s will be remained. So as it is cancelling. So now we can write this equation as dou p by rho into dou s plus g into cos theta plus v dou v by dou s is equals to 0. You can write like this. And from the diagram, if you consider, so this is a vertical direction through which the weight is acting. If you consider this as dz, the length of the fluid particle will be ds, and from this the cos theta is equals to dz by ds. If you substitute dz by ds in g into cos theta, so in earlier equation there is g into cos theta. If this cos theta is replaced from this triangle, it becomes dz by ds. So if you substitute dz by ds in this equation and multiply with the ds, the entire equation, then it can be written as dp by rho plus g into dz plus v into dou v. So after multiplying with the ds, so here also this becomes g dz, this becomes dp by rho plus ds will get cancelled v into dv. So this particular equation dp by rho plus g into dz plus v into dou v into dv is known as Euler's equation of motion. So this Euler's equation of motion is derived by assuming a steady flow equation and identifying a particular fluid particle which is flowing along a streamline, and considering the gravitational force and pressure force and the force due to its own weight, so that can be derived. Finally, the equation 3 is known as this equation is known as dp by rho plus gd jet plus v into dv is equals to 0. This equation is known as Euler's equation of motion. These are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.